Ryan Seymour here with Breeze Fabrication. Today we're taking a look at doing a short stroke coilover conversion on the AE86 Corolla. And we're going to be using the Cusco steel coilover sleeves. I've done this video a long time ago using aluminum sleeves. So now I'm going to be going through the process, just showing you how it's done on steel sleeves. So let's dive right in. So here is the AE86 stock strut casing in all of its glory. So first thing first, we want to remove this spring perch. We're going to be doing so with a 4.5 inch hand grinder outfitted with a cutoff wheel, also 4.5 inch. So I'm just going to come in here and cut away at this. Now it doesn't need to be perfect because I'm going to be cutting a 40 millimeter section out. And I'm just going to end up cutting the part where that spring perch sits. So we just want to cut it away so that way it'll fit into our saw. Now with the spring perch cut off, I've made my marks here and here where my cuts will be made to take this 40 millimeter section out. Now the threads on this inner diameter for the gland nut are pretty fine. And since we're going to be clamping this in the saw and then also welding, which tends to throw heat into a part and distort it, what I like to do is I cut the top off of a gland nut and put this down in here and tighten it up, so that way when I'm doing my cutting operation or my welding operation, I know that that inner diameter stays true. So why are we doing this? So what we have here is a representation of a stock damper with our stock travel. That's our stock compression stroke. But we're not running stock. We want to lower the car. So what happens is you lower the car and now your compression stroke is a lot shorter. So that leads to bottoming out the shock. So how do we combat this? So we cut 40 millimeters out of our strut casing so we can run a shorter damper. So if you see here, now we are at the same height as the lowered stock casing. So we are 40 millimeters lower, but we still have a good amount on the compression stroke. But in our case, the dampers that we run are a little too small, so we have to end up running a 20 millimeter spacer on the bottom of them. And this is pulling information off of the old Club 4AG website, which is still up in the technical reference and data section on how to do a coilover conversion. The reason why TRD made the dampers the length that they did was because they wanted them to fit a few different models. So the KP61 and AE92 being those mentioned. So in our case, we have to run a 20 millimeter spacer. For those other models, you might have to run a different spacer or no spacer at all. So that's why they made them that size, so that way they were interchangeable. So now that the pieces are cut, we want to deburr the inside of these and the outside. And we're going to come through and eventually we will be welding these two pieces together. So we want to get rid of all this paint in the area that we're going to be welding so we can get a nice clean weld. And I'm going to remove most of the paint with the Chicago Electric band file, which is a neat little tool that I got from Harbor Freight. Won't break the bank and it gets the job done. I'll put a link up in the description. I'll also put a link of where to get the belts. You don't have to buy them from Harbor Freight. You can get them from McMaster Car for less than $1 a piece. And I have no affiliation with it, but it's just a nice tool to use.
Okay, so we have the strut casing set up in a piece of angle iron and clamped in. So this piece, which is the top threaded part, is going to be welded here. So I like to clamp my strut casing in some angle iron to make sure everything's nice and true. But I've also made this fixture, which is a little, it's like round tube that I milled two opposing angles into, so as you tighten it, it opens up. It basically pushes on the outside, or pushes on the inner diameter. So that acts as an added heat sink and also helps keep everything in line. So one last measure before we tack everything up. And we are at 329 millimeters, which we measured 369 at the beginning, so that's exactly 40 millimeters shorter. So we are ready to go. So I am going to be using the gas tungsten arc welding process, also known as TIG. I'm going to be running about 130 amps DC negative using 332nd tri-mix tungstens from Diamond Ground Products. And my gas flow is at about 15 CFH. I'm using 100% pure argon. And I will be welding it with my go-to steel filler material, which is ER70S-2. So let's tack it up. I like tacking it and welding it as much in the fixture as I can. The whole point of this is to try and keep it as true as possible. So now with the top piece welded back on, our next step is to weld in place the coilover sleeve. But as you can see, it's having a little bit of trouble fitting over the sleeve, so we're going to have to grind that back down with a flapper wheel or a Dynafile. So now with that weld ground down, the coilover sleeve fits over. So this is a Cusco set. I believe the customer got it from righthanddrive.com or rhd.com. And I've seen the Cuscos before where they have a shiny finish to them. I've heard people say that the Cusco sets are cast. Coming from a manufacturing standpoint and my background in manufacturing, I think that would probably not make too much sense to cast a piece and machine it when they have nominal stock that's readily available that size. So my best guess with the silver ones are machine, and then the shiny part that welds a little funny is electroless nickel plating, which is a rust inhibitor. So I'm guessing now with this black finish, this is the first time that I've seen this black finish on them, that this is also a rust inhibitor, and also it kind of feels like a what may be a friction inhibitor. So these are steel, and the thread pitch on these is 2 millimeters if you kind of want to get into depth, but they use a 60-degree V thread, which is like your standard thread. So that would make sense if they had some type of friction inhibitor on it. Versus when you see more common on your aluminum coilover sleeves, like your T3s and your ground controls, they're a square groove thread, which is a stronger thread, but they're probably doing that to make up for the lack of strength of the aluminum, which there's nothing wrong with. Those are tried and true and they work. This is just another way of doing it. So I don't like this black coating. It probably will weld, but I don't like probably, so I'm going to chuck it up in the lathe and just shave it down a little bit to get a nice bare metal finish on it. And now we got those edges cleaned up a bit. So I'm going to put them an inch down from the top, and then I'm going to end up welding all the way around here and probably all the way around here as well. And I'll be using the same process with the same filler material, probably around 90 amps or so. We'll see how that goes though. So I did weld these guys up, and as you can see, the coating down here did burn off a little bit, but that's to be expected. So I don't know if these are designed to also be used on top of stock spring perches, or maybe not designed to be welded, but they welded up pretty nice. So I'll weld the other side, and that'll be that. So all in all, the set welded up very nice. One recommendation, if you do have the coated set, I would remove the black coating about a 1/4 inch back. If you see there, I'm not welding any of that coating. I don't want any of that coating to dilute into my weld and contaminate the weld. Other than that, they welded up really nice. Japanese steel, always a pleasure to weld. So this is Ryan Seymour for Breeze Fabrication, signing off.